So we are dealing with the second problem over here of paper 2 JEE Advanced 2025, and the problem is stating two coaxial conducting cylinders of length L with radii root 2r and 2r are kept as shown in the diagram. The charge on the inner cylinder is Q and the outer cylinder is grounded. The annular region between the cylinders is filled with a material of dielectric constant 5. Consider an imaginary plane of the same length L at a distance r from the common axis of the cylinders. This plane is parallel to the axis of the cylinders. The cross-sectional view of this arrangement is shown in the figure 2. Ignoring edge effects, the flux of the electric field through the plane is where epsilon naught is the permittivity of the free space. So the first thing that we need to understand is that the diagram is showing us one top view and the side view, which we can say. And what we are exactly going to do is that we need to find out the charge which this region contains. So over here, if I mark this one as point B, this as point A, then over here we mark it as A dash, and then over here we mark it as B dash. And then if I draw the lines such that we are connecting the centers, so we draw it like this. So this one we mark like this, another one over here, similarly on this side towards A dash and B dash. So the center we are marking it as O, and this point we are writing it as C, and this one as C dash. So over here, if we are approaching with this problem, the first thing that we want to find out is the angle which this region is containing. So the angle which this region is containing, that is we want to calculate first. Let us draw this axis. So we are referring this as x axis, and we can draw another y axis. So angle AOX. So if we are solving for angle AOX, so cos of angle AOX, so this one can be written as base by hypotenuse. So we get 1 by root 2, therefore angle AOX is equal to pi by 4. Now similarly, if we solve for BOX, so cos of angle BOX, cos of angle BOX is equal to r by 2r, and a half, that is angle BOX is equal to pi by 3, 60 degree or pi by 3. So over here the angle which it contains is pi by 3 minus pi by 4. So angle which this contains, so angle BOA is equal to pi by 3 minus pi by 4, that is pi by 12. Now this pi by 12 angle is contained on the either side, that is on this side as well as on the other side, that is over here. And this is what is responsible for the total charge enclosed inside this region. So if we are saying that the charge enclosed, so charge enclosed in this region or the strip AC is also equal to A dash C dash. So we are writing it as the total charge Q is distributed in 2 pi area, and over here we have a region of pi by 12. So we can say that the charge enclosed is Q by 24 on AC, and this is equal to the charge enclosed on A dash C dash. On A dash C dash it is containing the same charge. So the total charge which this region is containing, so we can say over here that the Q total which this region is containing is equal to Q by 12. And now we just need to do one line calculation. So for calculation of electric flux, phi electric flux, and since this region is a dielectric, so Q enclosed by epsilon r epsilon naught. So Q by 12, epsilon r in this case is 5 epsilon naught, we get Q by 60 epsilon naught, and it is matching with the third option, or option C. So option C is correct for this particular problem.